Hello there, welcome to the second video of this course. So today we are going to be looking at the linear Diophantine equations. So most of the times the types of equation that we see, if we say linear equation, it involves just one variable. So when we say a linear Diophantine equation, then it means that we have two variables in just one linear equation. So let's say that we have let a, b, and c be integers. A linear Diophantine equation involving two variables, consistent of two variables. Can be written as ax plus by is equal to c. So whenever you are being given an equation like this and you are being asked to find a solution to this, we have ways of checking if it is possible to solve it. So let's see. The first thing that you have to look at when given such an equation is, first of all, you have to check if the GCD of A and B is a divisor of C. So if the GCD of A and B is a divisor of C, then indeed a solution exists. If you find the GCD of A and B and the answer is not a divisor of C, then it means that we can't go ahead to find the values of A and B because there is no solution to the problem. So let's take our first example. So our first example is, if you are being given 2x plus 6y is equal to 7. Now how do we find this? Over here, this equation, first thing that we have to do is to find the GCD, right? So let's see. The GCD of 2 and 6. And what is the GCD of 2 and 6? We can go through the Euclidean algorithm. Or you can see over here that the GCD of 2 and 6 is indeed 2. So there's no need to even go through the Euclidean algorithm. If the numbers are not that huge, there is no need, you can tell from it. So now GCD of 2 and 6 is 2. Now we have to check if 2 is indeed a divisor of 7. Is 2 a divisor of 7? The answer is no. The divisors of 7 is 1 and 7 itself. So 2 can't be a divisor of 7. Since 2 is not a divisor of 7, so since 2 is not a divisor of 7, the equation the equation 2x plus 6y is equal to 7 has no, not just a solution, has no integer solution, has no integer solution. So you see, 2x plus 6y is equal to 7 has no integer solution. But what if we had this? 2x plus 6y is equal to 8. Are we going to get a solution for this? Let's see. Now, the GCD of 2 and 6 is 2. Now, that's 2 divides 8. Is 2 a divisor of 8? Yes, it's a divisor. So now, if 2 divides 8, then we can go ahead and find a solution to this problem. Okay, So now what you can do is, with this problem, there is a solution. Now let's move on to say a second example. A second example is when you have 5x plus 7y is equal to 3. So with this, the same thing. We have to check if the GCD of 5 and 7 is a divisor of 3. Now, what is the GCD of 5 and 7? If we have 7 going through the Euclidean algorithm, we're going to get 5 times 1 plus 2. So 5 is equal to 2 times 2 plus 1. Then 2 is equal to 1 times 2 plus 1. Sorry, plus 0. So the last non-zero number over here is 1. So GCD of 5 and 7 is equal to 1. So after getting to know that GCD of 5 and 7 is equal to 1, we have to check, does 1 divide 3? So is 1 a divisor of 3? Yes, indeed, 1 is a divisor of 3, so we can go ahead and solve this problem. Yes. Okay, so now the question given was 5x plus 7y, and this is equal to 3. So to solve this problem, what we have to do, let me copy this over here. So to solve this problem, what we have to do over here is to solve this equation backwards. The one we have over here. We have to solve this backwards. So we have this 1 to be the GCD. Now we have to make 1 the subject. In making 1 the subject, we are going to get 1 is equal to, we will move this over here to the left hand side. So we're going to get 5 is multiplying 1 over here. So there is nothing. Minus 2 and 2. So all what we are going to do is to make substitution, right? So over here, we are dealing with the remainders. So a remainder of 2. So we have to move this over here. So we have our 5 and 1 minus, we are now at 2. So this 2 is the same as writing 7 minus 5 times 1. And this whole thing is multiplying 2. I hope this is clear. So it's just substitution. We have this. So in place of this 2, we are going to put in 7. We are going to put in 7 minus 5, 1. Just a substitution. Okay. So this is the same as writing 1 is equal to. Now, over here, we're going to get, we have 5, 1 over here already. And this negative and negative will give us positive. So it's more or less like saying 5, 1. And this is 5, 2. Right? So plus 5, 2. Then over here, we're going to get minus 7. And over here is 2. So this is the same as saying 5, 3 minus 7, 2. So this is 15 and this is 14, which is indeed 1. So in this case, it means that we are going to have, and the question that was given to us is 5x plus 7y is equal to 3. But we notice that over here we have the same thing over here, but over here is 1. And because this is 1 and 1 is a divisor of 3, we can just multiply the equation through by 3. So if we multiply it through by 3, we are going to get 3 is equal to, note, we are not going to use the 3 to multiply what is in front. We are just going to multiply it with what is in the bracket. So we are going to get 5, 9, minus 7, and 6. So indeed, you can see that there's a similarity between this and this. We can rewrite this to be 5, 9 minus 7, 6 is equal to 3. So 5, 9 plus 7 and minus 6 is equal to 3. So in this case, we're going to get our x to be equal to 9 and our y to be equal to minus 6. So this is how to find a solution to this problem. 5x plus 7y is equal to 3. So first of all, you have to check if the GCD will divide 3. If it's a divisor of 3, you go through the Euclidean algorithm. Then after going through the Euclidean algorithm, you have to solve it backwards. Don't worry, we are going to solve another question. So, example 3. The example 3 is we have 7x minus 21y is equal to 49. So we have to ask ourselves, it's the GCD of 7 and 21. This is a divisor of 49. So let's see. GCD of 7 and minus 21. Note, from the first video, we got to see that this is the same as the GCD of 7 and 21, right? And this is equal to 7. After getting to know that this is 7, we have to check, is 7 indeed a divisor of 49? And this is, yes, it's a divisor, right? Okay, so now we have to go through the Euclidean algorithm. If you go to the Euclidean algorithm, you're going to get 7 is equal to minus 21 times 0 plus 7. And minus 21 will be equal to 7 times minus 3 plus 0. So you can clearly see that indeed the GCD of 7 and minus 21 is what? 7. Okay, after getting this, we have to solve this equation backwards, right? So if you are solving this equation backwards, then it means that you are going to make this 7 over here the subject. So you are going to get 7 is equal to, we will send this one over here, so 7 plus 21, 0. Now we have to compare this equation to this equation. We have 49, we have 7. Then meaning that we can multiply this equation through by 7. So we are going to 7 times 7 is 49. Over here, we have 7 is multiplying 1, right? Plus 21 and 0. So if you multiply through by 7, I'm going to get 7 plus 21 and 0, because 0 times 7 is 0. Now we can modify this and get 7 minus 21, 0 is equal to 49. So meaning that over here our x is equal to 7 and our y is equal to 0. So a solution exists. So that is how to solve any Diophantine equations. Okay, let's move on. You can also be asked to solve for a positive integers that satisfy a certain Diophantine equation. So, for instance, you can be asked to find this 167x. Let me write the question in full. So, find the positive integer. So the positive integers x and y satisfying the equation one 167x plus 43y is equal to 797. So when given this equation or when given this question, the first thing that you have to do is you have to check. You have to find the GCD of 167 and 43. So let's do that. So what is the GCD of 167 and 43? You see over here, it's not that easy to tell. So let's go through the Euclidean algorithm. We are going to get 167, which is equal to, over here, we write this as the quotient. Now, how many times will 43 go into 167? And that is 3. Then plus 38 as a remainder. We write the quotient again. So 43 is equal to 38. How many times? 1 plus 5. 38 is equal to 5, 7 plus 3. Then we're going to get 5 is equal to 3, 1 plus 2. So 3 is equal to 2, 1 plus 1. Then 2 is equal to 1, 2 plus 0. So we can see that the GCD of 167 and 43 is 1. So GCD of this is equal to 1. Now we have to check, is 1 a divisor of 1797? Is 1 a divisor of 797? The answer is yes, it is a divisor. So if it is a divisor, then it means that an answer exists. So we can go ahead. Now to find that, we have to solve this equation backwards. So let's do that over here. We have to make 1 the subject in this case, the last but 1 case. So we're going to get to 1 is equal to 3, which is times 1 already, minus 2, 1. So we send this over here to the left hand side. Okay. Now let's go to so we are done with this. Let's go to the second. Let's go to the second one. So the second one is we are making the remainder over here to the subject. So we are going to get 1 is equal to 3, 1 minus. So in place of 2, we are going to have 5, which is multiplying 1, minus 3, which is multiplying 1. Then we write this one. I hope it is clear. Yeah, so this is what I'm going to do. Then over here, you just group them. So you're going to get, we have 3, 1 over here, 3, 1 over here. So 3, 2 minus 5, 1. So we are done with the second one, second remainder. So we have to go on to the third remainder, which is 3. So we are going to make 3 the subject. If we make 3 the subject, over here, this is 3. We are going to get 38 times 1 minus 5 times 7, and it is multiplying 2 minus 5 and 1. So this is the same as having, we have 38, 1 over here and 2 here. So 38, 2 minus 5. So 5, we can see that 7 times 2 is what? 14 plus 1, which is 15. The reason why it is plus 1 is we have negative, making it positive. So plus 1. Okay. So now, if you want to see if you are correct, 38 times 2 is 76. Then 5 times 15 is 75. So it's indeed 1. So we are also done with the third one. Now let's go to the fourth remainder, which is 5. So we are going to get the same thing, minus, now making the 5 the subject, we are going to get 43 times 1 minus 38 times 1. Then we have to bring this 15. So 38, we have 2 over here, 15, so making 17. So 38 times 17 minus 43 times 15. Okay. Now we are done with this. Let's move on to the last remainder. And in the last remainder, we are going to get 38. So make 38 the subject. So 167 minus 43 times 3. Then all times 17. Then minus 43 times 15. So we are going to get 167 times 17 minus 43. So 317 is 51. 51 plus 15 is what? 66. So this is the answer. 1 is equal to 167 times 17. You can check this on a calculator. You are going to get 1. So now, because 1 is a divisor of 7, because this one is a divisor of 797, we can just multiply this equation through by 797. You guessed right. So we are going to get 797 is equal to 167. Then 17 times 797 is 13549 minus 43. 66 times 797 is 52602. Okay, so after getting this, comparing this to our equation, we can see that our x is 13549 and our y is equal to minus 52602. Now the question asked us to find the positive integers satisfying this. So the positive pair of integers satisfying this, we have formulas that we use in checking or in finding those kind of solutions. So we have these formulas. So the formulas are, the first one is, we have x is equal to x naught plus b over the GCD of a and b times t, and we also have y is equal to y naught minus a over the GCD of a, b times t, or we can also have s is equal to s naught minus b over GCD of a, b times t, and y is equal to y naught plus a over GCD of AB times t. So it's either you use this or you use that. But the best way of choosing this, if over here, in our case, we got s to be positive. Now, if s is positive, we have to go with this formula, this approach over here. So if x is positive, then we have to go with this. If both were to be positive, if x and y were to be positive, we would have gone with the first formula. But if x is positive, y is negative, we have to go with the second formula. So now we have to find the value of x. So we know, let's copy that formula. So we have this formula over here. And we also have x naught, we have x naught to be equal to 13549 and y naught to be equal to minus 52602. Now, when you have this, you are just going to do substitution. You are going to get x is equal to 13549 minus b, and the b in this case is 43, so minus 43 over the GCD of a and b. So the GCD of a and b was 1 over 1. We are still going to get 43, so times t. Our y will be equal to y naught, which is minus 52602, plus our a, and our a was 167. So 167 over the GCD is 1, so it's the same thing, times t. And because we want positive pair of integers, we have to resolve this. Inequalities. So we are going to get 13549 minus 43t, because we want positive integers. This should be greater than 0. Also, minus 52602 plus 167t should also be greater than 0. Now, since we have this, we want to find the value of t. So in this first case, we are going to get minus 43t is greater than minus 135.49, then we are going to get this. So t, if we divide through by negative, so less than, so we're going to get 315.09, and in this case we're going to get 167t is greater than 52602, which means t is going to be greater than 314.98. So over here we know that t is greater than 314.98, but it's less than 315.09. So it means that t is approximately 315. Okay. Now now that we have our t value, we can just plug it in back into our equations. So we're going to get s is equal to 135.49 minus 43 times 315, and this is equal to 4. We're going to have y to be equal to minus 52602 plus 167, then times t, and t in this case is 315, and this will give us 3. So x is equal to 4 and y is equal to 3. So these are the set of positive values that satisfy the equation 167x plus 43y is equal to 797. I hope this is clear. So now let's move on to the last part. Okay, so the last thing that we are going to treat today is if you have an equation of this form. So when you have an equation of this form, how do you solve this, right? So an example is, if you have this 8800x is equal to 24 in modulo 100, how do you solve this? Whenever you are being given a question like this, you have to resolve this into a linear Diophantine equation. So you're going to get 88x plus this 100, so 100 y, and this is equal to 24. Now after doing this, you have to check for the GCD. So GCD of 88 and 100, this is equal to 4. So the GCD is equal to 4. Now you have to check, is 4 a divisor of 24? Yes, indeed, it's a divisor of 24. Then it means that a solution, an integer solution, does exist. So if an integer solution does exist, we have to go to the Euclidean algorithm. So you're going to get 100 is equal to 88 times 1 plus, I think, 12. Yes. Then 88 is equal to 12 times 7 plus 4. Then 12 is equal to 4, 3 plus 0. So indeed, the GCD is 4. Then we solve this equation backwards. So let's move on over here. If you are solving this backwards, then it means that you are making 4 the subject. So you are going to get 4 is equal to 88, which is times 1, minus 12 times 7. Then we go to the next remainder, which is 12. So 4 is equal to 881. Then in place of 12, we are going to put in 100 times 1 minus 88 times 1, or multiplying 7. So 4 will be equal to 88 times 8 minus 100 times 7. So as we've been doing already over here, because 4 can divide 24, we know that if you multiply this equation through by 6, you are going to get 24 over here. So if you multiply it through by 6, you're going to get, I'm going to get 24 is equal to 8, and 8 times 6 is 48, minus 100 times 42. So let's rewrite this. We have 88 48 minus 100, 42, and this is equal to 24. Now, when you get this is the same as writing, since we are dealing with modulo 100, you're going to get 88 modulo 100 multiplying 48 minus 100 modulo 100 multiplying 42, and this is equal to 24. Now 100 times 42 modulo 100 is 0. So we are going to get 88, 100, 48, and this is equal to 24. So if you compare this with the equation that was given over here, if you compare this to this, then we can see that x is equal to 48. Do you now understand? Now, if x is equal to 48, sometimes we have to note this. If x naught is a subset of Zn in the solution of the equation then all solutions are of the form sk is equal to s naught plus n out of the GCD of A and N T, where the T is a subset of 0, 1, then the GCD of A n minus 1. And also you have to note that if an equation of the form A n x is equal to B has a solution, then it has GCD of A n solutions. What do I mean by this? So in this case, we have 88, 100 x is equal to 24 in Z100, right? So what do I mean by this? First of all, we want to check the number of solutions that can satisfy this equation. So x, so we got x naught to be equal to 48, and to find the number of solutions that are going to satisfy this, that is when we find the GCD. So the GCD of 88 and 100 is equal to 4. So this meaning that we have 4 different solutions. Now, since we have 4 different solutions, we have to find our T, and we know that our T is a subset of 0, 1, then GCD of 88 and 100 is 4 minus 1, which is 3. So this will be our T. Now, to find x1 will be equal to x naught plus n, and now n in this case is the 100 over the GCD of E and N times T. So this is x naught plus 100 over GCD of this is 4 and T. So in other words, x1 is equal to x naught plus 25T. You understand? So this is equal to s naught is 48, then plus 25. Now when T is equal to 1, we are going to get we are going to get 73 over here. So this is our x1. Now x2 will be equal to x1 plus 25T, and this is equal to 73 sorry, not T again. (73 plus 25, right? And this is equal to 98. X3 will be equal to X2 plus 25. And this is equal to 98 plus 25. And this is equal to 1, 2, 3. But note that we are dealing in modulo 100. So this modulo 100 is equal to 23. So the values satisfying this equation are, we are going to get, the first one is 48, then we had 73, then we had 98, then we had 23. So these are the values satisfying this equation. So if you have to put this back in, if you have 8800, 73, this should give you 24 in Z100, meaning that if you multiply 88 and 73, then modulo 100 you should get 24. 88 times 98 modulo 100 you should get 24. I hope this is okay. So this is the end of today's class, and I would like to give you some questions to try. I'll provide the solutions in our next session. So try these. 1. Solve the following equations. So E is 143, 374, X is equal to 17 in Z374. The B is 287945. X is equal to 35 in Z945. And the second question is over here, determine all pairs of positive integers. Satisfying the equation 644x plus 1477y, and this is equal to 7651. Thank you for listening to me, and if you really like this video, give it a thumbs up and subscribe to our channel. See you later. Bye.